We have a resource for multiphoton characterization of biological molecules here at MSU. That resource we measure carefully two-photon spectra and cross-sections of different biologically relevant molecules. And we do this measurement for most of the researchers, and those people are across the country and even from other countries.
Having a facility like the Multiphoton Research Lab here in our department is really important for our research mission because it's a very, very unique resource.
And this resource is supported by the NIH grant, and NIH supports that because we have a unique optical setup, expensive equipment, which other people don't have in their labs. Multiphoton spectroscopy is an important tool because it provides information of the optimum wavelength of laser to excite the molecules with two-photon mode. And it can compare quantitatively different probes because we measure the two-photon cross-sections and quantum yields of fluorescence. So we measure the brightness of the molecule upon two-photon excitation, and we can compare those brightnesses for different probes and molecules.
What Misha can do is give you high quality, high resolution data regarding the actual two-photon properties of the probes you're using, whether they're fluorescent proteins or dyes. And this deep physical insight that you can get is invaluable.
Our collaboration got started when my lab started working on a protein that uses heme, or we thought would be binding heme. Does heme bind to RSAD1? How tightly does heme bind to RSAD1? And does heme bind anywhere in the vicinity of the iron-sulfur cluster, which is where we believe the catalytic active site is for this enzyme? RSAD1 is a human radical SAM protein. We don't know its function, but in recent years it's been implicated in Alzheimer's disease. It's been shown that in Alzheimer's disease brains, RSAD1 is significantly higher abundance than in control brains, and so we are interested in understanding how that enzyme works, what its role is in Alzheimer's disease, and what its biological function is. The Multiphoton Lab is helping us in this project because they have sophisticated fluorescence, spectroscopic instrumentation that allows us to get information like the lifetime of the fluorescence. And the lifetime, we are learning, is being impacted by the presence of the iron-sulfur cluster in RSAD1.
One of the major research thrusts in my group is to develop new proteins and biosensors that we can use to analyze biological systems. And so we looked at including a halogen atom, dimerizing the molecules, or including styral substituents. We weren't really sure how each of these modifications would impact the photophysical properties. And it was really with Dr. Drobyshev's assistance that we were able to begin to probe sort of the structure, function, photophysical property relationships in these fluorophores.
There's a couple ways to engage with Mikhail's laboratory, and one is through workshops that he has that are actually open internationally. And we advertise that from anyone from undergrads to professors to actually take that workshop. Then there is also just access. You know, he will have undergraduate students that will take this as a research project and get credits for it. Then on campus, he's always looking around to say, you know, somebody looking for a probe, to develop a probe that they can work with. Most people don't realize right now that this resource is right here, and they're having to look at other companies or look at other directions, but not realizing that he can technically tweak those probes that they're trying to make and do it right here. And so the access for everybody is a little unique in that regard, and you can have workshops or directly go and work with the investigator. So a lot of opportunities for access.
Dr. Drobyshev has brought a community together through his extensive collaborations, really in all areas of science, from synthetic chemistry, molecular biophysics, as well as cell biology, imaging, and really has established a community through his collaborations. And this sort of culminates in this annual multiphoton meeting that he provides to be able to bring all of his collaborators together in one venue and really help establish new collaborations across disciplines.
If you're a basic scientist with a new fluorescent protein, a new fluorescent biosensor, a new dye, things that can be used in two-photon microscopy, you can obviously do the one-photon characterization, but I would encourage you to consider collaborating with Mikhail Drobachev's laboratory to get detailed two-photon photophysics from your probe. It'll help you, it'll help the field.
We are very open for collaboration. Please send us your samples. Please contact me via email. We would be very happy to characterize your new probes, fluorescent molecules, fluorescent proteins, the sensors based on fluorescent proteins which you make in terms of their two-photon absorption properties.